All right, guys, we're finishing the review sheet today. So we stopped on number 15. We're going to pick up on number 16. 12x squared plus 17x plus 6. And the first thing we're going to look for is a greatest common factor between these three terms. And there is not one. 6 and 12, yes. But 17 kind of throws everything off. Yes. The next thing we're going to do is find the sign. Since the third term is positive, our signs are the same and match the sign of the middle term. So we'll have plus and plus. 3, or that one there, math, and it's just down in that list. Our next point is to find the factors of the first and third terms. So we're trying to find the factors of 12x squared and 6. Well, our x squared will be x and x. Now our factors are 12, 1 and 12, 2 and 6, 3 and 4. Which one of these do we want to try first? One and 12.
It's 3 and 4.
3 and 4. 6. Is 1 and 6 or 2 and 3? 2 and 3. Where do we want to put the 2? Where do we want to put the 3? 2, 3. This again is a side note and kind of a reminder. If there's not a greatest common factor to begin with, there can't be one in either set of parentheses. And the reason that this is kind of nice to know is because, well, I can't put 3 there because 3x and 3 would have a greatest common factor of 3. We could factor it out. If we could do that, that means that there was 1 to begin with. There's not 1 to begin with, so 3x and 3 can't go together. That also means 4x and 2 cannot go together. So it kind of helps us remove certain factors. That means this has to be 2. This has to be 3 if this is going to work. And again, we can check the middle term. 3x times 3 is 9x. 2 times 4x is positive 8x. 9x plus 8x is 17x. So those are the terms that we wanted. Questions on this here? We good with 16. We ready for 17. 8x cubed plus 27 is their greatest common factor between these two terms. And 27. No, because factors of 8 are 2, 4, and 8. 27 is not divisible by 2. It's not divisible by 4 or 8. But our x cubed is telling us that there is a possibility that this is a sum of 2 cubes. Now our cubed root of x to the third is x. Now we can calculate the cubed root 2. So the cubed root of 8x cubed is 2x. Cubed root of 27 is 3. And we can do that in the calculator. 3 cubed root 27 is 3. So that does tell us that this is a sum of 2 cubes. Parentheses with 3 spaces, parentheses with 5. Our signs are the same, opposite always end on a positive note. We're starting out with a sum of plus, so to be the same, our first sign would be plus. Opposite would be minus, And our our last sign would be plus. Always end on a positive note. Plus minus plus. First set of terms are 2x. So in the first spot we would have 2x. Bigger set of parentheses, we would have 2x squared. The middle would be 2x to the first. And in our last spot, we would not have any 2x terms. And our other term is 3. Wouldn't have anything with our 2x squared. But in the middle would be 3 to the first. And our last one is 3 squared. Questions on how we got to this point here? Now at this point, we would simplify. Here we'd have 2x plus 3. Right? We would square our 2x squared. 2 squared is 4. X squared is x squared. 2x times 3. 2 times 3 is, and we still have our x. Plus 3 squared is 9. So we have 2x plus 3 times 4x squared minus 6x plus 9. And that's it there. Questions on this here? All right. There's no question on that one. We're going to move on and look at number 19. $40x squared plus 172x minus 36. Is there a greatest common factor between these three terms? At least 2. And we could start with 2. And we can factor it out. And if we factor 2 out of 40, we have 20x squared plus 2 factored out of 172 is 86x. And 2 factored out of 36 is 18. Is there another greatest common factor? Because it'd be another 2, which would be 4. It will become 4. But we can take 2 again out of these three terms. If we factor 2 again out of 20x squared, we get 10. If we factor the 2 out of 86, we have 43x, and 2 out of 18 is 9. Now it does become 4 because we multiply these common factors together, and our 2 times 2 becomes 4. So the greatest common factor for this was 4. Now if we don't immediately see that, we can factor out the ones we do. So 2, 20, 86, and 18 still have another common factor of 2. We can factor it out again. And we multiply those common factors together to get what the greatest common factor would be. So it does work out that 40, 172, and 36 are all divisible by 4. Any other questions on this here before we move on to look at signs? Since the third term is negative, the signs are opposite. One's going to be positive. One is negative. Now we're going to look at the factors of the first and third. Well, with our 10x squared, we will have x and x because it kind of matches up to our middle term of x. Factors of 10 are 1 and 10 or 2 and 5. Which one do we want to try first? Two and 5. And again, I'm just plugging these in, 2 and 5. Now the factors of the third term, 9. We have 1 and 9 or 3 and 3. Which one do we want to try first? 3 and 3. And the last thing we can do is check 2x times negative 3, negative 6x. Positive 3 times 5x is plus 15x. And negative 6x plus 15x, negative 6 plus 15 is 9x. And we're trying to get to 43. Well, we could try switching the 3 and 3 But that wouldn't do anything, would it?
I think we should try one.
So we can try 1 and 9 next. Now we could have switched the 2 and 5, but most likely all that's going to do, 9 over here. Okay. Yeah. If we'd switched the 2 and 5, it would have just changed the signs of what we had
Oh, yeah, that's right.
with 3 and 3. Now here, 2x times -1 is -2x. 9 times 5x is positive 45x. And -2x plus 45x is 43x. Is that the middle term we wanted? Yes. Questions on this here? We good with this here before we look at 22? $31,250x cubed y minus 93,312y. Yes. Is there a greatest common factor? Yeah.
Oh, what is it? Why?
Because they both have y, yes? They are both even, so there could be a greatest common factor of 2. Now 31,250. We could take the cubed root of 31,250. Well, it gives us a decimal, so there's definitely a greatest common factor. 31,250 divided by 2 is 15,625. Well, we can try taking the cubed root of it, and we get 25, yes? So that does verify that 2y is probably the greatest common factor, because here we get 15 1, well, 1565 x cubed, as we factor the y out, minus, and we could divide 93,312 and get 46,656. And we could try taking the cubed root. Now, we've already taken the cubed root of 15,625 x cubed. And we found that the cubed root of 15,625 is 25. And well, the cubed root of x to the third is just x, because the cubed root and the third power simplify out, giving us x. Now we will also need to take the cubed root of 46,656. It is indeed 36. And we are able to say this is a difference of 2 cubes. So we can fill in our parentheses with 3 spaces, parentheses with 5. I made sure to make the spaces a little bit bigger this time because yesterday, with the one problem we had, everything got a little squished. So making them a little bit bigger so we can actually see them and read them. Our signs are going to be the same. Opposite always end on a positive note. So same would be minus. Opposite would be plus. Always end on a positive note would be plus. Now, even though we do have some significantly big numbers, it doesn't change any of the steps in this process. Because our first term is 25x. Inside the bigger one, in the first spot, we would have 25x squared. In the middle, we'd have 25x to the first, and that's the last thing we do with our 25x. The other spot is 36. We're not going to have anything with our 25x squared, but in the middle, we would have 36 to the first, and in the last one, we would have 36 squared. So our 2y and our 25x minus 36 would stay the same. Now the next thing we're going to need to do is square 25x. We're multiplying it by itself. So we're saying 25 times 25, which should be 625. And our x times x is x squared. Our next step would be 25x times 36. 25 times 36 is 900, and we would still have our x. And our last step would be to take 36 squared, 36 times 36. Should be 1,296. Yes. And as impressive as that might seem, me just throwing those numbers out there, I've solved this problem 3 times today. So solving it the 4th time, you kind of have the numbers down. But again, even though these numbers are massive and kind of big to work with, the calculator could have done all this for us, except for the x squared. 25 squared, we can plug in the calculator. 25 times 36, we can plug in the calculator. 36 squared, calculator can do all that. They give us the numbers and we just plug it in their respective spots. And we're done. Questions on this here? We good with this one here? These sum and difference of perfect cubes seeming easier and easier each time we do these. Let's look at 23. So there's a good chance this is a difference of 2 cubes. But again, is there a greatest common factor? And it would be? Because 8 does indeed go into 8x cubed and 64. And if we factor an 8 out of 8x cubed, we're left with x cubed. If we factor an 8 out of 64, we're left with 8y cubed. All right. Now we're going to take the cube root of both of these here. The cube root of x to the third is nice because that's just x. Cube root of 8y cubed, well, we would have y. And the cube root of 8 is 2. Now our signs for this are going to be the same. Opposite. Always end on a positive note. Since it was difference, our first sign is minus. Opposite of that would be plus. Always end on a positive note would be plus. Our first term to plug in is x. In the bigger spot, our first spot is going to be x squared. X to the first, and then no x term in the last spot. Other spot's 2y. So we have 2y. We don't have a 2y with our x squared. The middle spot would have 2y to the first. And the last one's going to have 2y squared. Now at this point here, we're going to have our 8 times x minus 2y as we simplify the first set of parentheses. Won't simplify any further than that. But the second set of parentheses, we do have some simplifying. Our x, the quantity x squared, is just x squared. Our x times 2y is 2xy. And lastly, our 2y squared. 2 squared is 4, and our y squared is y squared. Because when we square these here, we're multiplying it by itself, so we're saying 2y times 2y. Our 2 times 2 would be 4. Our y times y is y squared. Yes. Questions on 23? So 24, again, the first thing we're looking for is the greatest common factor. Looking at these 3 terms, we do have some variables. Well, a is in common with all 3, yes? And it's just going to be a to the first because the smallest exponent attached to all 3 is 1, so we can only take 1 out of all 3. We do have b. We have b squared, b cubed, and b to the 4th. So we can take out a b squared. Only one of them has c, so we can't factor c out. Now the next question is there a greatest common factor between 186, 9, and 117? Well, maybe. What are the factors of 9? 1, 3, and 9, yes? We can pick 117. And we can say 117 divided by 9 is 13. 117 divided by 3 is 39. So 9 and 3 work with 9 and 117, yes? And the other one was 186 divided by 9 is decimal number. So 9 is out. It only works with 2. 186 divided by 3 is, so the greatest common factor is 3. So if we see a greatest common factor that works with 2, go and try it on the other one and see if it works. If it does, it is a greatest common factor or a common factor. If it doesn't, throw it out. So here we're going to divide all of these by 3ab squared. 186 divided by 3 is 62. We factor an a out of a cubed, we're left with a squared, and the b squared factors out completely. Minus. When we factor a 3 out of 9, we're left with 3. A factors out completely. 2 of the b's factor out, leaving us with 1. And we do have c. Plus, I about started to write 117. Plus 39, because when we factor a 3 out of 117, we have 39. We remove one of the a's from a squared and just get a. And when we remove 2 b's from b to the 4th, we're left with b squared. Now, there's 2 main spots where this tells us it's not factoring. One is the c, because c only shows up in one spot, not in kind of a systematic way. That kind of tells us it doesn't factor anymore. Now, if it had simplified down to something like this here, 62a squared minus 3ab plus 39b squared, there is a chance it could factor. Because we have the ab in the middle, there is a way that this could actually work out and factor. But since we don't have that there, and the fact that our third term is ab squared, it's throwing a lot of things in the middle. So this here is as far as we can factor it. Questions on this here? Questions on anything we've done so far? We ready for 25 and 26? Well, they're not on the test. Nope. There's not a single one for factoring by grouping on the test. (27) and 28. Again, first thing we should always be looking for is the greatest common factor. 12x cubed minus 144x squared. Is there a greatest common factor? 12, yes. And they do both have x in common. And more specifically, we can take x squared out of both, yes? If we factor 12 out of 12, it factors out completely. And if we factor an x squared out of x to the third, we're left with x. We still have our minus sign because we didn't do anything with the signs. If I factor 12 out of 144, we're left with 12. We're just dividing it. And the x squared factors out completely, yes? Questions on what we've done so far? Inside the parentheses, we only have one x, yes? And the exponent attached to it is 1, yes? Whenever the exponent, or the degree, so x minus 12's degree is 1. Whenever the degree drops below 2, it's simplified. The only way we could factor it if there's still a greatest common factor, we already got rid of it. Done. And that's it. 15x squared plus 30x. Is there a greatest common factor? 15x. And if we factor 15x out of 15x squared, we're left with plus 30 divided by 15 is 2. And the x factors out completely. If a term factors out completely, it reduces to 1. Questions on 27 or 28? We'll look at one more. X to the fourth minus 32x squared plus 256. Even though it's x to the fourth and x squared, this still behaves the same way as our other quadratics. So our factors of x squared would indeed, or x to the fourth would be x squared and x squared. Because if you notice those first two terms, because when our middle term was just x, our x squared is x and x. The term was x, so it works out that way. Here, x to the fourth, well, x squared times x squared is indeed x to the fourth. Now our x squared plus x squared would give us our middle term. So it still works the same way there. That would give us x to the fifth. X in the third and x, it possibly, but we would need other variables for that to work. Because we would need an x cubed term and an x term for that to work. Does that make sense? And at that point, we would be factoring by grouping. Now, our signs still follow the same rules. Since the third term is positive, the signs are the same, and they match the sign of the middle term, which would be negative and negative. Factors of 256. The first one's nice. 1 and 256. Since it is even, we know 2 and 128. And we can plug this in a calculator. 3 does not work, but 4 does. 4 and 62. 5 does not work. 6 does not work. 7 doesn't work, but 8 does. or 64. 64, 8 and 32, and then 16 times 16. 16 and 16. And we can check this here. X squared times negative 16 is negative 16x squared. Negative 16 times x squared is negative 16x squared. And negative 16x squared minus 16x squared is negative 32x squared. Is that the middle term we wanted? Yeah. So let's just look at the first set of parentheses. What's the degree of our x squared minus 16? The degree? So the degree is? So we said if it's below 1, it's finished. Yes? Here's the degree is 2. So there is a chance it could factor. Yes? And we have two terms being subtracted. The only one where we had two terms being subtracted and one of the exponents was 2 was a difference of perfect squares. Yes? Is x squared a perfect square? X and x, yes? Is 16 a perfect square? 4 and? So that means that our x squared minus 16 is factorable, yes? And what would it factor to? X. Well, we'd have minus and x and plus. What times itself is 16? So our x squared minus 16 would factor to x plus 4 and x minus 4, yes? Wait, don't we have another one of it? Yes. Because either one of these are the correct answer. But as we see here with these here, the graphing, or not graphing, but the factoring, even though we're talking about x to the fourth and x squared, didn't really change. The process didn't change for what we were doing. It's just that there's another step beyond it. And we kind of see that there. Yes. Yeah, I can help you in ACT. This here, so I've said this before to y'all, that college algebra is essentially going to be algebra 2, just a step beyond. This is one of the steps beyond. So it's doing the same type stuff, we just have a little bit more to it. Yes.